Hello, everyone, and welcome to the Practical Python Application Series. So, as opposed to some of the other videos that we put together that are more high level, basic concepts on what Python can do and how to use it, this series is more about creating something with those concepts. So, if anything I go over in this video is unfamiliar, I encourage you to go back and look at some of those videos. Everything that's covered in this video should be covered already in one of those conceptual videos. In this case, we're going to be looking at creating a centralized ledger. The idea is that you have a program running that can have multiple people assigned to it. And when they create an account, they are giving an initial allocation, let's say 100 of whatever it is, a fake digital currency. They can then check their balance and they can transfer some of their value to someone else, which will take away from their balance and add to somebody else's. All this is being used in a centralized system. Um, and let's take a look at the requirements here. So again, centralized ledger. We've got two parts here. We got a centralized ledger and a user node. The ledger is going to give initial allocations. It's going to track the transfers in a ledger file, and then it's going to return balances when queried. The individual user nodes are going to be able to query their current balance, and they're also going to be able to transfer some of that balances to others. So here's a little bit of what it would look like. So, three main concepts here. We got three nodes, Alice, Bob, and Chuck. This is the ledger itself, or the ledger program. So one thing you can do is have Alice request a balance, passing in her name. It'll open a ledger. It'll look for everything with Alice inside of it. It'll add all the credits where values are added to her. It'll subtract all the debits where she has sent something away, and then return the final balance back to Alice. You can do a transfer. So let's say Bob wants to transfer from himself to Chuck, sending 10 of the instance. So similarly, it'll open the ledger. It'll add a line for a debit of 10 for Bob and adding a credit of 10 for Chuck. And then it'll save the ledger. And then initializing, let's say Chuck wants to initialize, it'll open the ledger and it'll add a credit for Chuck. So as I go through these series and these applications, it's not going to be a fully autonomous program. There are going to be rooms for improvement, but these are going to be a baseline to kind of set the stage for what Python could be used for. The idea is that you can use these to improve your individual projects that you're working on, and learn from some of these mistakes by doing. So some of the things that is not covered within this is getting the balances of other users, although the concept is pretty similar to getting your own balance, validating that a person first has enough balance before they transfer, using digital signatures and verification. So I can't just say I'm Bob and I want Alice to send to Bob, because currently the system will allow that. So if we have a digital signature, then we can do some verification. If the message is not valid, then we reject it. And then, of course, we can have some exception handling to make it a little bit easier. Other stuff that we can look at in the future is setting this up to run over Python sockets, a network connection. However, I haven't released a video on that yet, so we can just keep that in the background. So let's take a look and get started. All right, so we're going to get started here on a video covering a more complex topic. So this one, what we're going to do is we're going to create a basic centralized ledger system where you can create an initial allocation. You can send some balance from one person to another, or you can check what your current balance is. So the first thing we're going to do here is we're going to create a new file, and this file is going to be for our ledger. So the ledger is just going to keep a record of all the different instances that have occurred. So one of the things we're going to need to do here is let's say we have a ledger file. So let's create a definition. And in this case, again, thinking about what we want to do, we want to be able to have the ability to add value, to initialize, and to query. So in this case, let's do one to add a value first, or do a transfer. So we're going to need some information. So we're going to need who. In this case, we need two nodes. So we're going to need a from, a to user, and a value. So let's assume the ledger already exists. So we're going to call the ledger file ledger.txt. So we want to do this in a read mode. And we're storing all the content in here in this content variable. And then we're closing our access to that file. Okay. And now we're going to add a new line. So in this case, the new line is going to say so let's just start off a new line with a colon. Actually, let's not. Let's do a simple value first. So we're going to have from user. We're going to use string plus. Now we'll put a colon. All right. So basically, let's say we're sending from Alice to Bob. This will put something like if that's what we have in the values passed. Okay. So now we're going to open up the ledger again to write. It should be ledger. Now we don't want to necessarily just write over it. So if we open it up as W, that's going to overwrite everything in there. But we want to append. And then we will say f dot write. I'm not sure what's going on down there. There we go. And we're going to write our new line plus a backslash n for a new line character. Oh, I'm getting errors here because I'm not in the proper indentation. And then we'll close it. Now, let's also say we want to query a value. We need a target user. And that's essentially all we need. So it's going to be similar. We're going to use this reading. And all the values are stored in the content. Now we can say balance equals 0. We'll just set it for an initial value. And then for L, for all the lines in content. So it's going to iterate through each line of the file one by one. And then for each one, we're going to, we're expecting everything to have this format, a starting, an ending, so a from, a to, and then a value. So we can say, we can use the split function to split each line even further. So what this is going to do, we have our line value. We're going to take the current line we're on inside of our list. It's going to split it on this. So in this case, it'll create 3 instances, 3 indexes, 0, 1, and 2. So if the line value at index 0, so it's coming from this user, equals the target user. So if it's a from, so in this case, it's sending out of this user, it's a debit, then we're going to say balance equals balance minus the line value at the second index. So this is 0 index, this is 1 index, and this is 2 index. If, say, taking the same concept, if it's at the to field, then we're going to do plussing the line value. And then when we're done, we'll have the balance value and we'll just return the balance. The last thing we really need to do is initialize for a user. So we need a username. So this is going to be similar to here. And in this case, we can actually call this same method. So I'm going to move it down here. So we can call transfer value. So we're having one method call another value. The default for this, we'll call it ledger. It's going to go to the username. And then we'll say 100. So what this is going to do, it's going to look like, so let's say it's Bob. So it looks very similar to this, except this is just a keyword. All right, so that seems pretty good for our ledger file. And let's do one more, a startup. Well, no, because we don't want to overwrite the ledger. So in this case, I'm just going to create a ledger file that we're looking for so that it exists. All right, so now let's create a a node. So we'll call this node1.py. So this one, let's say we have a prompt to determine what the user is. And then we can have an infinite loop for this so that it'll continue to go and just say while true. Well, actually, let's create it as a variable. So in this case, we're basically creating a while loop that'll continue forever until a specific condition exists. And let's create a method for our prompts. All right, so let's give those two options. So what it should do is we'll do menu display. So it's going to essentially prompt this up. And let's have it actually return something. And we'll just do a prompt like that for the user. So now, since we're getting a response from menu display, we'll say menu display. And let's actually add one more here. Okay. Now we can do a real quick check. If response equals 3, then should continue equals false. So this is how we will get out of the loop. Now we need to check if response is equal to 1. So we're going to check our balance. So what we're going to need to do here, we have our ledger file. We're going to import that. And we'll say dot query balance. We're going to pass in our user. We'll change that to username. All right. And then we'll say balance is equal to that. And we'll say print all right. So we got that. If response is equal to 2, Then, okay, so we're going to send it to another person. Then in this case, we're going to do ledger dot transfer value. We're going to pass it from us, so username, to, in this case, we need to prompt the user. And then we need to have all right, so we got those items. Okay. And now anything else, we're just going to do a pass. So that it says if it's not one of these expected results, we're just going to continue, which will make should continue equal to true, and it'll prompt the menu again. Now, one thing I did realize here when we're transferring the value and for querying the balance, we have balance here being an integer, but we're getting this line value at item 2, and that's still a string. So we need to convert that to an int. And same here. Okay, so now we're doing transfer value. I don't think we actually need this right now. Yeah, we shouldn't need that. So let's delete that. All right, and let's take a look at what we can do here. So real quick test, we can do Python node 1. All right, so it's going to enter our name. I'll say Bob. All right, we can get all these answers. So let's say I put A. Well, it's not a valid response, so it just sends a menu again. Let's check our balance. Our balance is currently 0 because in the ledger file, there's nothing in there. Okay. Let's say in this case, we're not doing any error checking. So let's do 2. Who do you want to send to? Let's say Alice, who again doesn't exist. Send 100. But we do see that the ledger gets updated. Bob, Alice, and okay, so we can see an error here that we didn't anticipate because I haven't added a colon there as well. Okay, so we can take care of that. Let me zero this out. And we can test our quit. Okay, so we quit. Okay, so we need to have a code to initialize as well. So when we first create a user, let's say so we're just going to do the same thing here. and we'll do an if statement. All right. So now when we first run this, it's going to ask us the name. If we look at the ledger file, we now see that Ledger put in Bob for 100. So if we check his current balance, we can see he has a balance of 100. So at the same time, I can create another node here. Or technically, we don't necessarily need to create a new node here, but if we tried to expand this further and have different executions, we could do the same thing. But I can actually just create a new window and run Python node 1 again and call this Alice. Let's look at our ledger file. So we now see Alice and Bob have the same amount. So this currently logged in as Alice. Let's say Alice wants to send to Bob 30. Okay, so we see one line for Bob getting 100, Alice getting 100, and a line from Alice to Bob 30. So let's check her balance. She properly has a balance of 70. If we go to the other one and have Bob check his balance, he has a balance of 130. Other things that aren't necessarily being conducted here is if we say, let's have Alice send a balance to Bob with a capital B and want to send 10, we can see that, what did I do here? Oh, I went from Bob to Bob with a capital B. So let me go over here and try it again. So we're going to send from Alice, this is Alice's instance, to Bob with a capital B again. I'm going to send 30. We can check her balance. Well, she now has 2. So she had one where she subtracted 30, one where she subtracted 30. She started with 100, so she has a balance of 40. If we have Bob with a lowercase b check his balance, he still only has a balance of 120. That's because in this case, there's a difference between lowercase Bob and a uppercase Bob. So this should be enough to kind of get you started with a concept of how you can use this. Other things that can be added, of course, is validating that somebody has enough balance ahead of, before they actually send something. Using digital signatures to ensure that only a message that comes from Bob can send stuff to Alice. Because even though it's encoded right now, you can theoretically, set it up so that if you modify the node code, if you take in another value of, sending from Alice to Bob when you're Bob, you can kind of hack your way around that and send it from Alice. But if you have digital signatures, that would be caught. So you can do some type of validation within the ledger itself. Other type of stuff that you can do, you can, excuse me, you can put this out on a separate file, a separate location, specifically when we get into like sockets and stuff, so that nobody else can have access to the ledger.txt file. Right now, I can manually go in and modify this stuff. You can have error handling if for something happens to the ledger.txt file. Maybe it doesn't exist, then it would throw an exception and the file, the whole system would crash. So all kinds of different things that you can use to implement your project. But this should be a baseline to help you get started on your own projects. So hopefully you got something out of this. Again, more videos like this coming in the future as we go along. If you have any questions, feel free to leave a message or leave a comment, and we'll go from there.
Good news, everyone.
That's right. Good news, everyone. This is Doc here. You made it to the end of the video, which means you liked it. So please click on the thumbs up below the video. If you have any comments, anything else you'd like me to see put a video together for, leave a comment, ask any questions. And of course, more videos like this are coming, so be sure to subscribe.